So in number 60, we have an unstable nucleus with that initial mass. Initially, it rests in the coordinates of or origin of a coordinate system. It disintegrates into three particles, and then they give us the mass and the directions of each. And so I've drawn those over the side. Another particle of mass that moves in that, find the magnitude and direction of the velocity of the third particle, which I kind of drew in light blue right here. Well, we can very quickly figure out the mass of the unknown particle, assuming that the total mass is constant. Oh, by the way, total momentum before and afterwards must add up to zero. In this case, the mass of the unknown particle, the sum of these three is equal to the parent particle, 1.7 times 10 to the minus 26th. And we can probably pretty much guess if the total momentum beforehand was zero and the total momentum afterwards is zero, our unknown particle is going to be traveling somewhere in this direction. Now, how can the total momentum add up to zero? Well, again, we tend to like to work in horizontal and vertical directions. This particle here, moving horizontally, has some horizontal momentum of that. Just mass times velocity gives us that. And the vertical one up here has a momentum of this. For the total momentum to be zero, this momentum, which is acting at an angle, must be or must counteract or be exactly opposite these other two. I'm going to draw it separately down below. So, for example, our unknown particle, light blue particle here, must have a momentum that's exactly equal but opposite to this momentum over here. It also must have a momentum that's exactly equal and opposite to this momentum. To do that, it's got to have both of these together. Its momentum must be the vector sum of these, and I don't know, it doesn't look very perpendicular here, but it is, which gives us this. That's the momentum of our unknown third particle. Now we can very quickly calculate its velocity. Why? We know momentum is equal to mass times velocity. In this case, the momentum of our particle is what we just found there, the hypotenuse of that triangle. Its mass from up here above, 3.6 times 10 to the minus 27th, times v. And if we solve for v, you'll get its velocity. That tells us how fast this particle is moving. 1.25 times 10 to the 7th meters per second. Pretty doggone fast, but it doesn't give us the angle yet. So our last step is to find the angle, and forgive me for my pen being really slow. And so we just have to find theta. And to do that, you could do any of the arc sine, arc cosine. I'm going to do arctangent, 3 over 3.36. Arctangent of that gives us our angle here is going to be about 41.8 degrees. Here's the magnitude of the velocity and the angle that it's traveling at. And yes, we even know the mass of our unknown particle. Congratulations. You hopefully should understand this one. See you soon.